Hello students. So today we will continue with the topic determinants. Okay. Till now we have seen how to calculate a determinant. Okay. Now we'll study about the properties of determinant. So first property, okay, it says the value of determinant remains unchanged if its rows and columns are interchanged. Okay. So if you have a determinant, say matrix, say A1, A2, B1, B2. Okay, then if I interchange the rows and columns, okay, then the determinant of this will be same as determinant of this. So this is basically our transpose, right? So determinant remains same if the rows or columns are interchanged. Rows and columns are interchanged. Okay. Then second property is if any two rows or columns of a determinant are interchanged, then sign of determinant changes. So if you have, suppose, one matrix, okay, and one of the row or one of the columns you are interchanging. Okay, so suppose we have a matrix, say A3, if I am changing, suppose, this first row and third row interchanging, this will be C1, C2, C3. Then determinant of this matrix will be equal to negative of this determinant. Okay, so the sign of the determinant changes. You can take any example and verify this. Okay, let's move on to our third property. If any two rows or columns of a determinant are identical and all corresponding elements are same, then the value of determinant is 0. Now suppose we have a determinant, say 1, 1, 1, 2, 3, 4 and 1, 1, 1. So these two columns are identical, right? So the determinant of this matrix will be 0. So any two rows or columns of a determinant are identical, then the determinant value is 0. Okay. Now fourth property, if each element of a row or a column of a determinant is multiplied by a constant, then its value gets multiplied by k. Now suppose there is one determinant, say A1, A2, A3, B1, B2, B3, C1, C2, C3, and I am multiplying a constant to this row. Okay, then the determinant will be multiplied by k. Okay, so this is the difference between matrix and determinant. When you multiply a scalar to a matrix, it gets multiplied with all the elements, right? And when you multiply a scalar with a determinant, it gets multiplied with any of the row or the column. Only one row or only one column. Okay. Now by this property we can take out any common factor from any one row or any one of the column. Okay, so we can make use of this property and we can take out this common factor from any one row or any one column. It should be from any one row or any one column. If corresponding elements of any two rows or a column of a determinant are proportional, that is in the same ratio, then its value is 0. Okay, so suppose this element and this element, again ratio of this and ratio of this are proportional. Okay, then we can say that the determinant is 0. Okay, now property 5. If sum or all elements of a row or a column of a determinant are expressed as a sum of two or more terms, then the determinant can be expressed as sum of two or more determinants. Okay, so suppose we have a determinant, say a1 plus lambda 1, a2 plus lambda 2, and a3 plus lambda 3, and this is b1, b2, b3, c1, c2, c3. Okay, then we can express this determinant as sum of two determinants, that is a1, a2, a3, b1, b2, b3, c1, c2, c3 plus lambda 1, lambda 2, lambda 3, b1, b2, b3, c1, c2, c3. Okay, next property, if to each element of any row or column of a determinant the equimultiples of corresponding elements of other row or column are added, then the value of determinant remains the same. That is, the value of determinant remains same if we apply the operations, say Ri, Krj, or Ci, Kcj. Okay, that is when we are applying the row operations or the column operations, the value of determinant remains same. Okay, so these are the properties, and there is one remark also. Okay, if there is one determinant, say delta, okay, and if we apply a row operation, say Ri, k into Ri, that is we are multiplying a scalar to that row, entire row, or a column operation. Okay, then the determinant becomes k delta I. That is that this is from previous property, that is scalar gets multiplied with the determinant. Okay, so there is one more remark. It says if more than one operation like this, okay, adding, is done in one step, care should be taken to see that a row that is affected in one operation should not be used in another operation. A similar remark applies to column operations. So if we are applying one operation to this row, then the next step this row should not be affected. Okay, we have to apply another operation for another row, not for the same row. Okay.